Okay, so today we're going to work on this graph, which is kind of what we started on in class, but we didn't get very far. So I'm going to start towards the beginning, and then we're going to work our way through. So our end result should be this graph where we have these 8 players, 1, 2, 3, 4, 5, 6, 7, 8, yep. These 8 players, and we're kind of getting the hit profile for each player for these short season of 2020. Okay, so we have home run, triple, double, and single. So in this case, I'm using a stacked bar chart instead of kind of like a grouped bar chart, where like a grouped bar chart would be for each player, there would be 4 different bar charts representing a single, double, triple, and home run. Well, some of these players, they don't have a triple, or I guess all of them have a home run, but yeah, some of them don't have triples. So that would just be this kind of empty blank space for that grouped bar chart. It would look a little weird, so in this case a stacked bar chart is better. Alright, so we're gonna make this. Okay, so I've done some things that we've already done before, but I just want to already get them kind of out of the way. So the first thing is making our title, clearing the memory, starting our first section, which is called bookkeeping. Have a comment to import our data. We import the data that we want. Remember that these 2 dots and this /, this means to go back 1 folder. And then I tell MATLAB that our data is in the folder called data. And then our file is called angels2020.csv. Okay, here we find the players that we have. There's 22 of them. I didn't want to look at all of them, so I removed some of them here. So we only have 8 players that we're going to look at. Next thing, I convert the column called player name from our main table over here called T. So I converted that from a cell to a string so we can use logical operators like our equality logical operator. And then the next thing I did is I specified the type of events that we're going to look at for this. So here you could definitely argue that I hard-coded this, maybe. But if we do unique of t.events, there's a ton of stuff, and there's 20 of them. Yes, I could delete the ones that we don't care about, but in this case, really, it's more simple to just actually type out the events that we want to look at. So that's what I did. Alright, so now we're on to the data reduction part. So we're going to use 2 different methods here to highlight the differences for speed. So the first one is going to be using find and length. And the second method is going to be only using logical operators and then using sum instead of length. And you'll see that the second method is going to be faster. So I'll show you that in the end. And we're achieving the same thing here, but doing it in a slightly different way. Also, I should mention I still feel some side effects for my second dose, so if I sniffle or something, it's because I still feel a little sick. So fair warning for that. I'm gonna try to stop the video, but if I don't, yeah, yep. Okay, so first thing we have to do is find our indices for each player. So we have 8 players here, and we have to find all of their indices. This is something that we've done before. I forget in the last video if we used find or if we used our logical operator. I think we used find, but whatever, I forget. Doesn't matter though. We're going to show both methods today. So I'm going to make a cell array because there's going to be a different amount of rows for each of these different players. So we can't use like a matrix or a table, because if we use a matrix or a table, every single column needs to have the same amount of rows. Okay, so we're going to do find when t.playerName, so we're looking at our table T in this column, when that is equal to, in this case, the very first name for this cell array that we have here. Okay, and so I know that we've done this before, so I'm just going to get all of these players right now as well. Alright, so if we run that now, and we'll open this up, And there we go. So we have all of our indices for all of our players. Alright, so yeah, you can see that all of these, they have a different amount, or a different size, basically. And that's why we're using a cell array. Okay, so now we're going to find the amount of singles per player, doubles per player, triples, and home runs. So this is when it's going to get pretty tedious, and it'd be better to use something like a for loop, which we're going to learn in the next week. But before we do that, and we're not using for loops for the first project either. So before we do that, we're going to be using the methods that we've learned thus far. So let's first find basically all of the rows for our first player when they hit a single. So I'm going to do hits 1, 1, and this is going to be a cell array. And we are going to say, I'm going to first show you something like that. So let's do hits 1, 1, and we're going to say find t.events. Then we're going to use array addressing for our first player, so we get all of those rows. And we're going to say find when that is equal to event of 1. Okay, so we'll break it down one more time. So we're going to find all of the rows when t.event, so this column here, for player ind1, so for the indices for our first player, we're going to check when that was equal to the very first string in our cell array called event. So actually that was a string array. No, oh no, not that. So single, okay? So we're going to find all of those rows. If I run this right now, we're actually going to get an error. Okay, and it says that the size of the left side are not compatible with the size of the right side. Okay, and this is occurring because we're specifying the size over here for hits to be 1 by 1. That is a scalar. So we only have one row and one column. But over here, the actual output that we have here is not a scalar. It's actually going to be, I think it's actually a 13 by 1. So there's basically 13 instances when Joe Adele got a single. And we can actually confirm this here. So let's do let's do length of find t.events of player ind1 is equal to event of 1. And we get an answer of 13. Okay, so that's where we have the issue. If we wanted to change this and we didn't want like a cell array here, we could do that. So let's do colon, comma 1. And now this will, oh god, it clipped again, sorry about that. So now this runs for us, and basically we're telling MATLAB to, no matter the size here, so it could be 13, it could be 10, it could be 225, it could be whatever. But because we put this colon here, we're saying get however many amount of values that we have for this, and it's gonna work out. So let's open hits, and there we go, we have 13 values here. Now, point of note here. Okay, so these are indices, right? Because we used our function called find. So this is going to be similar to our last video when this can be misleading. So you might look at all of these and be like, all right, cool, this is going to be the 12th row and then 135th row and so on for our table T. So let's check it out. So basically our 12th row and our table T, it should correspond to when an event here is equal to a single. Nope, not true. Also, you might think that it should correspond to when our batter was Joe Adele. Not true. It was Anthony Bamboom. So remember, it's actually the 12th index for our player index, or our player indices for our first player. So it's really this 12th index for player ind1, which is really the 155th row in T. So let's check this out. Let's go to 155. And here we go. So we have Joe Adele, And let's make sure that he got a single, and yep, he got a single. Alright, so you want to be careful about that once again. So if we were just gonna add on length here, that would actually be okay. You know, because this is still going to be true. Joe Adele hit a single 13 times. And that's because, again, you know, those indices all here, they are referencing the respective indices for player IND1, which then reference some indices in our table T. So we could do that, and technically that would be fine. But if you actually want to specifically, you know, be able to check our table T and see that it's Joe Adele and that he got a single, we're going to have to put all of this stuff here and this stuff here on one line, kind of like we did last time. So I'll comment this out for now, and let's put a comment before. Be aware of indices that are referenced below. Okay, so here we go. This is the kind of correct method, which is similar to what we did in the last video for the percentage stuff. So what we're doing on one line is basically finding all of the indices for our first player, and at the same time we're checking when t.events is equal to event of 1. Okay, so let's break it down a little more. So we're looking at just our table T here, and we're first finding when t.playerName, so when t.playerName is equal to names of 1, so that's Joe Adele, and on top of that we're saying and find when t.events, which is column 9, find when t.events is equal to event of 1, which is a single. Okay, so it needs to satisfy both being the name of Joe Adele and t.events being equal to single. And what we get is all of this. So we have a 13 by 1 double, and this is looking good now. This is what we saw earlier on for our kind of double layer inception thing, if you want to think about it that way. Okay, so remember, like up here, it was the 12th, I think it was the 12th row for player IND, which, yeah, is row 155 for table T. But here we're getting it directly. So this is saying directly that row 155 is for Joe Adele, and he got a single then. So here we see it's a single, and here we see it's Joe Adele. The next one is row 2656. Let's check that. Alright, so we got Joe Adele, and we have a single. Looks good. Okay. So at this point, let's do it for the, actually, so we're also going to make this a cell array now, because there's going to be an issue. Let's first show the issue, I guess. So we're going to do it for all of our other players. So basically, we're going to do for all of our other players here. So this would be from 1. Oh my gosh. Let's go down here. No, not what I wanted. There we go. So 1 to 8. And then 1 to 8. Okay, so let's run this, and we get an error because the size of the left side, they even tell us the size now, is 13 by 1, and the size of the right side is 50 by 1. Basically, we're getting this issue because, you know, again, all of these rows for player by player is going to be different. So we can't have this as a matrix because all of these columns have a different amount of rows. Alright, so we gotta change this to a cell array. Let's do that. Let's do this. And now if I run this, then it runs okay. Let's open up hits. And you see for the first one it's 13 by 1. For the second one is 50. Third one is 16, and so on. Alright, so there we go. That's how we do that. And the next thing is to find the amount of doubles per player, triples per player, and home runs per player. So to do this, all I'm going to do is copy this section, copy and paste all this stuff. Okay, and then we're going to change this to be, actually no, this should be 1. Oh boy, sorry, I'm off my game today. So let's make this 1. This will be our first cell. Down here, this will be the second cell. Here, the third cell. And then here, the fourth cell. Okay, and then we also need to change this stuff over here to be event of 2. So that'll correspond to a double. Next one, we need to change this to be 3. That'll correspond to a triple. And then the last one, we need to change that to a 4. That's going to correspond to a home run. If I run this now, cool, we got an error. Something with parentheses on line 47. One is our very first one, too. Oh. What? I thought I put a 1 there. Okay. Here we go. Alright, so there we go. We have all of our cells and all of our values here. You see in row 3, some of these are empty cell arrays. That's because those players didn't have a triple. So some of them do, not many. And you know what I could have done too is actually just directly say, find the length of this, and we can do that too. But let's double check something. Let's take some random cell here. Let's do this one. So we're in row 4 and column 3. So row 4 and column 3, that's right here. So that's the amount of home runs for player number 3. Okay, so who is that? Names of 3. That was Shohei Ohtani. So we can look at our table T for these rows, and we should be able to double check that he had a home run on these rows. So let's go to row 509. We see it's Shohei Ohtani right there. And let's double check here. 509, look at that, he got a home run. Looks good. Let's check one more. 1085. 1085, we see it's a home run. Let's double check it's Shohei Ohtani. And it is. Cool. So it's working out. Alright, so there we go. The next thing is we're going to do the same thing now, but using logical operators and sum. And then we're going to compare the amount of time that it takes to calculate or to run the script for both of these sections. Okay. So here we're going to find the amount of singles per player, and we're going to do it using our different method using logical operators only, meaning that we're not going to use find, and we're going to use the sum function as well. So the sum function is going to be kind of our replacement for the length function. So before we use that though, let's do this. Let's run this and then I'll explain it. So here we're going to basically look at our table T, and we're going to use a logical operator to check when T.playerName is equal to names of 1, Joe et al., and when T.events is equal to event of 1, which is a single. Alright, so we can check this now. So this is hits log that's opened up, and because it's a logical operator that's used, we're only going to be getting a result of a 0 or a 1. So just because, you know, I remember from up here that the first time this occurs is on, actually I forget now. I was going to say row 255, is that correct? No, it's not. Okay, so let's check. So hits of 1, 1, So first shows up on 155. Okay. So on 155 we should see a 1. Oh, look at that, we do. So again, this is corresponding to basically tell us that on row 55 of our table T, that our player name is equal to Joe Adele, and he hit a single on that row as well. So let's confirm this. I guess close that out too. So on row 155, we have Joe Adele, and he hit a single. Looks good. Alright, so that's what we can do instead. And we also want to find the amount of singles that were hit per player. Okay, so let me just do this first. And then let's make this 1 to 8. There we go. So up here, we currently have a cell array for hits. Let's open this up. So we have a cell array here, which is fine, but actually we want to find the amount of singles per player, the amount of doubles per player, and etc. So to do that, we need to use our length function. We'll do it like this so we can see it a bit better. I'm going to go over here. Okay. I could have done this a bit better before. Oh well. Okay. And let's do this over here. Length. One more. Length. Get you. Go over here. Okay, so let's run this now. And then let's open up hits, because that's what we just changed. Okay, and yeah, it's already opened up. So it's still a cell array. We can actually change this as well, because it's not really needed now. But you see that we just directly have just scalars in each of these cells. So because we have a scalar in each cell, we don't really need a cell array. So I'll change that too. Okay, let's just do that. Yeah, okay, this is okay. I'm gonna do a little thing in my text editor here. And then we'll do one more. Okay, so here and there. Son of a mother. On line 77. Oh, okay. Oh, I forgot to get this guy. I'll change him really quick. No, not a 0. Not a 0. Come on. Okay, run it. There we go. And you see hits. It's the same thing now, but it's a matrix now. It's not a cell array. Alright, there we go. So you see that, like for player number 1 here, he had 13 singles, player number 2 had 50 singles, and so on. Looks good. So now we want to do this for hits log. We want to get the same kind of thing here. So currently we have essentially the indices for when each player hits a single. But remember, it was this logical result that we have. So on 155 we have a 1. So I could like get the values. Well, I could get the values for the rows if we wanted. That would be using the find function, but we don't want to do that right now, right? But if we want to find the amount of singles per player, instead of using length, we have to use the sum function. So we're basically going to add up all of the times when we have a 1. And in that way, it's going to give us basically the length for how many singles each player had. Okay, so let's do that. We'll do sum. We'll run this now, and we'll go back here, And you see that we have just an answer of 13, which is correct. For our first player, he had 13 singles. And looking at our other method, it tells us that he had 13 singles. Also, again, we don't need a cell array anymore because we're just looking at a scalar, how many times each player did something. So let's change this. T-way matrix. Okay, we run this again. And now it's just going to be this one scalar here. Okay, yeah, that's fine. So let's look at hits here. Oh, never mind, it's not fine. I forgot. Yeah, we need to change our array addressing over here. Instead of just being all for player 1, which is what we currently have, we need to do it for players 1 through 8. Okay, 1 through 8, and this we're leaving as a 1 because we want to look when each player had a single, and remember, event of 1, that corresponds to a single. So let's run this again, and now it's correct. You know, we have 13, 50, 16, and here we have 13, 50, 16. Looks good. Alright, so now we're going to do this for doubles, triples, and home run. So I'm going to do the same kind of thing I did before. I'm going to copy all these sections here. And I'll just do some slight modification. Okay, so we have hits, and then I'm going to change this to a 2. I want to put our doubles in basically the second row here. Okay, and then we need to change this over here to be a 2 as well. Because we want to look at doubles now. Remember, event of 2 is a double. Next one, we want to make those a triple. So that's 3. This one down here, we're going to change it to a 4 for a home run. And let's also change our rows here. So for triples, I want to put that in the 3rd row. Dang it. Okay, 3rd row. And then for home runs, the 4th row. I'll run this now, and then hits log, there we go, and hits, there we go. Looks like I have, oh wait, no I don't. I was looking at the wrong part. So, they're the exact same. Let's confirm it though. Let's take this out of there. So, 13, 50, 4, 13, all the same there for our first 2 columns. Let's go to columns 3 to 4. Okay, 3 to 4, 16, 20, yep, all the same once again. 5 to 6, I mean, you can already have good faith, but it's all going to be the same. 7 to 8, all the same. So we have now achieved the same thing using 2 different methods. So again, what we did in general here is we found the amount of hits per player using 2 different methods. So we found the amount of singles per player using 2 different methods, and the amount of doubles per player using different methods, and so on. So our first method was using the find function, and the length function. Okay, and then our second method was using the just logical operators and the sum function. So what I'll do now is actually show you the differences in speed for these. So I'm going to start them here. You know, I'm not going to do this indices part because, you know, in the end we actually didn't really use these here, at least not for this part. We actually found the indices in each line of code, like here, okay? So let's show you the difference in speed. So to do this, we do tick and talk, no one say it. And then down here, we're going to do tick tock as well. Again, don't even think of saying it. Okay, TikTok. Okay, I'm gonna quit right now because this difference in speed is best seen when you actually run the script for the first time. And that's because, once we run the script, I think MATLAB kind of stores some of these variables in its memory, okay? So you can see the difference better on the first run. So let's put this like this. Let's run our script now. Okay, and you see here, for our first one, we have the elapsed time is 0.013 seconds. And then for the other method, using just our logical functions, it's 0.122 seconds. So is it a huge difference? No. But if you're using a lot of data, then that difference will start to add up. Let's do it again. Okay, so 0.01. Oh, actually, did I? Yeah, I did quit out. And then this is 0.010. So again, is it a big difference? No, it's not. Let's do it one more time. Okay, 0.014, 0.011. Okay, so it's faster. Alright, and sometimes, depending on the functions that are used, this difference will be even more apparent. So in this case, it wasn't that drastic, but in some other cases, it'll be more apparent, like I said. Alright, and the last thing we're going to do now is work on our plot. Alright, let's, I don't need to. I was going to open the workspace, but we don't have to. Okay, so we're going to make our bar chart now. So let's do bar of, first let's just do bar of hits log, okay? So here we go. So this is not a stacked bar chart, it's just a bar chart, right? But this isn't really what we want. We want to do this basically on a per player basis. And right now, this is actually on a per hit basis. So number 1, this is for singles, 2 is for doubles, 3 for triples, 4 for home runs. I don't want to do it like this though. So it does matter on the size of the matrix that you're plotting for your bar chart. So let's do size of bar, not size of bar, size of hits log. That's a 4x8, so it's basically taking this value here and it's putting that along our X domain. So that's the hits, remember, and A corresponds to our A players. So let's instead transpose this, and now we have this on a per player basis. So we have 8 players, so we have 8 X ticks here, and basically 8 grouped bar charts, where blue is going to correspond to singles, red, doubles, yellow, triples, and purple home runs. We're going to add in X tick labels and a legend as well, of course. But this doesn't look all that great too. It's kind of hard to really get a good understanding at a glance of what's going on here. So it's better to use a stacked bar chart. So to do a stacked bar chart, we add on the argument called stacked. So here we go. But again, we have 4 hits here, 4 hit types. I want to do by players. So I'm going to transpose that. And now we have it by players, okay? Actually, I could run this again. Let's run this, and then I'll keep this over here. So let's add in our X tick labels. So X tick labels. And to grab them, we're going to just do names. Run it. And we've got all of our names there. Oh yeah, you see the difference in time now is even smaller. And it's because, again, MATLAB kind of stores some of the compilation that we've done in its memory, I think. Because the difference in time is much more apparent on the first run for the script. Okay, and then let's do X tick angle, and to make that a 45-degree angle, so we can read each of the player names better. And then we also need to add in our legend. So let's do legend. And that's just going to be the hit types that we have. That was called event. Run that. There we go. So single, double, triple, home run. Home run looks funky, right? So it's because of that that little underscore that we had. MATLAB doesn't really like that. So we're gonna have to change this actually manually, unfortunately, but that's okay. So we're gonna do legend, and we're gonna do in brackets event of 1 to 3, and just to see what this looks like first, it's just gonna give us those first 3 values. And after this bracket, we're gonna type in home run. Oops, this bracket should be over here. Home run. And there we go. So now we have home run that is displayed normally. Okay? So we kind of had to hard code that part, I guess. But that's because of the issue with the underscore. Alright, so I think that's it. Oh yeah, let's add in our title. So we can do title of hit profile for Angels players in 2020. See, I hard-coded 2020. If we don't want to hard-code 2020, let's say we had multiple years for our data sheet, you know, we wouldn't want to hard-code the date. So we could change this as well. Let's close this for now. Let's open up T. Okay, I want to put this over here. So you see that we have 2020 in this column here. But if I want to access that, I need to actually access just that year, right? Let's make a comment called access the year. And to do this, we have to use a function called dateVec. So we'll do, I'll call this dates. And then I'll say dateVec of t.gameDate. Okay, I don't want to look at this right now. Let's comment that out. And let's open dates, and you see that what it did is it broke up this datetime vector here into different columns for the year, the month, and the day. And it even does it by the hours, minutes, and seconds, but we don't have that data, so it just gives us zeros for that. Okay, so I only want to look at basically the year, so that's this first column. And if I want to reference that in our plot, I can do that as well. So we're going to say num to string of dates. And I just need to get one value here, so I'm just going to put 1. Okay, and now let's run this again. Okay, I need to put in a bracket here. I always forget that. There we go. And there we go. So it says hit profile for Angels players in 2020. Looks good. Let's make sure that I actually covered everything for this plot. And we can also double check that it's correct. Try to get these the same size. Alright, so there we go. It's the same. I need to add in the Y grid as well. But there you go. You see that we have the same plot. Alright, so let's add in this Y grid, those lines there. So to do that, we do AX equals GCA, so AX equals get current access. We can get all of the access properties. Then we'll do AX.YGrid equals on. There we go. Now we have our lines there. If I didn't suppress that comment, you see that we get some of those properties. I don't want to see them, so suppress it. And one more thing, if we want to export our picture, we use this function here, export graphics. We need to put AX to get this axis, or to get the axes. Then we'll specify our title. I'll call this class, or I'll call it vid stacked. And then we specify the resolution, 300 dpi. Before I run this, so actually, because I don't here. So let's make a directory called figures. Okay, so let's say that I want to save my figure that I'm about to export directly into this directory. So to do that, I can do .. that'll take us out of this code directory. So currently we're in here. I want to go out of this directory to here. and then I want to go into the figures directory. So to do that, we go out of the code directory, and we go into the figures directory, and we're gonna save this as vid_stacked. Alright, let's run this. Now let's go back here and look, there it is. There is our graph saved into vid, or saved as vid_stacked in our figures directory. Cool, so this will save you time on the project, because you're probably going to be writing your script a lot of times as you kind of work through it and work through some of the kinks. And so using that export graphics function, that'll help you out so you don't need to manually save your figures so often. Alright, so that's the video. I'll probably have like one more video, I'm guessing, and then that'll probably be it. But yep, okay. Hope you liked it. Let's actually do one more thing. Why not, right? Let's add in another player like we did last time. So let's do yeah, let's take this last guy out again. So basically I wanna keep him now. I don't need to run that. So let's then do well, let's open up names. So now our last guy is called Taylor Ward. And let's do, you know what, why not? Let's actually, sure, we can have him, and let's also do I guess 2 to 4. So now we have for for names we have, so we're adding in Jason Castro. So we're adding in 2 different players, Jason Castro and Taylor Ward. Okay, so let's go down here. Let me go to the bottom of my script. I don't want you to export right now. So basically I need to add in 2 more rows for each of these. I don't think I referenced this ever again, so I'm gonna skip that part. Let's go to hits. And we're gonna do 9, 10, 9, 10. And this again is why looping would be so much easier. I wouldn't have to add in these other 2 lines now. So 9, 10. I could do this a bit better, I guess, but whatever. 9, 10. 9, 10. And I didn't do this for hits log, so I'll need to plot this instead of hits log. It's going to be the same thing now. So we're going to change this to be hits. Okay, and now let's run this again. And look, there we go. So I ran it again, and now we have 10 players. And we have our data for these 2 new players as well. Jason Castro right here, and Taylor Ward over here. And so I didn't have to type out anything else. I just added basically 2 rows for all of those things. And that's it. So no hard coding required for that. But again, using a loop would be so much easier. So we're going to learn how to do for loops pretty soon. And you'll see how much better it is. So, alright, that's the video. I'll see you guys next time.